All right, today we are going to talk about some of the reporting requirements around software bill of material reports and why that can be a challenge and maybe some ways to solve the problem. I want to thank the organizers in this track for inviting me to talk about this because I think it's kind of an important issue when it comes to vulnerability tracking and potentially remediation. So we're going to go over kind of 4 points. Most important, why SBOMs are critical for CVE response and remediation, how they can be used, why we have Executive Order 14028, why it is important to understand some of the issues in decoupled architectures. Most of what the government's doing right now is still in VMs and probably much of it's monolithic still. And SBOMs in monolithic environments are easier to manage than in decoupled architectures, and we're going to talk about that because we know the government's not going to be on VMs forever. And we're going to talk about some OS tools out there that you might check out while you're here. Some of them will be coming from open source, OpenSSF, Open Source Security Foundation, and the Continuous Delivery Foundation. That's in track, what is that? I think it was 3C. What was the track I always walked in? I think it was, it's down there. 3C. It's 3C. Okay. I am Tracy Ragan. I am the co-founder of a company called DeployHub. I am also the co-founder of a company called OpenMake Software that's been around for literally 30 years. It's still out there and running, where we used to generate build control files, Ant scripts, and make files to solve the problem of not really vulnerability, but library management during C and C++ years. I'm on the board of the Open Source Security Foundation. I'm on the board of the Continuous Delivery Foundation's Technology Oversight Committee, and I also work on a project called Ortelius, which is why I'm wearing a giant alien t-shirt and alien socks. And you can get these in 3C, and there's a bunch, so please go get them. Okay, I'm going to ask the question because I ask questions. How many of you understand what a software bill of material report is? Okay, most of you do. There's some who didn't raise their hands. I'm assuming that you were not listening to me because I would guess by now that SBOMs are well known within the industry. That has not been the case for a very long time, I'm just saying. So SBOMs, in my world, I realize that SBOMs offer a lot of benefits, especially around licensing. But in my world, the most important thing about SBOMs is the open source packages, transitive dependencies that we are unaware of consuming when we build our containers or even our monolithic applications. So it's not just about licensing anymore. It's really about exposing the software supply chain. And this is really the discussion that's being had, is about the software supply chain, which I really don't like that term, to be quite honest. It's transitive dependencies. Let's just call it what it is. It's transitive dependencies. And we have built an amazing network, a Death Star of transitive dependencies that we have to learn to manage at this point. Because I don't think anybody's going to go back now and stop using open source security or open source packages. So we have to figure out how to move forward. And they can be catastrophic. Vulnerabilities are a problem. If we think about, a few years ago, we were talking, everybody was talking about Log4j, and most of us have gone to sleep again and forgot that Log4j happened. But it happened, and it was a very, very bad problem, and it cost $9.5 trillion globally for that one vulnerability, according to IBM X-Force. And the worst problem, our bad is that we're taking more than 100 days to remediate vulnerabilities, while bad actors are exploiting them in less than 10. So why are we sitting on our hands and not fixing the vulnerabilities? I've been asking that question for a very long time, and I'm trying to get to an answer, and the Ortelius project is helping with getting to that answer. Because if you think about the world of chaos engineering is an essential piece of really fixing problems in production fast, worrying about root cause analysis later. We're taking a chaos engineering approach to remediating critical and high-risk vulnerabilities. So the mission of Executive Order 14028 was to really strengthen our cybersecurity posture. And when I say our, I'm talking about the U.S.'s cybersecurity posture, in particular the federal government. It was part of understanding how to protect our critical infrastructure, how to protect our defense. And that has to do with understanding what potential packages are we sucking up through the transit dependencies that may have even been created by a bad actor, but we're still used to using it, that it's just become normal. And it could be normal to use a vulnerability that might be a moderate or a low risk vulnerability, and we don't care. And I kind of agree with that. But we have to start understanding when they really impact us and where they impact us. So while Executive Order 14028, I think it was a great step in the right direction. At the same time, if you don't consume this information about SBOMs, why are we using them? Why are you asking me for something that you're just going to stick in a file system? That's my frustration with it. The results of this order was to really influence the procurement policies around how software is being consumed by the US government and understanding what is being added to the risk stack when it comes to open source packages. The idea is to do this continuous vulnerability or a continuous authority to operate. To say we know what open source packages we're using, and technically, if that's the case, we should know when we're impacted by them. So this was to fit into this continuous authority to operate. And it's also part of NIST 800-218, the Secure Software Development Framework, which tomorrow we will be talking about in depth in 3C between 12:35 and 2 o'clock in the CICD Cybersecurity Focus Group. So what's required? Your SBOM must list all your components, especially open source dependencies used in software sold to the federal government. That actually came directly from one of the documents. The requirement is supposed to help agencies identify and respond to vulnerabilities quickly, but it doesn't happen. The US government is taking over 100 days to fix this stuff, so it's really not necessarily happening. But there is a goal from the DoD in particular to continuously assess and track vulnerabilities on all software assets. The real linchpin to this process is the SBOM, but the SBOM alone doesn't finish it. So when we think about an SBOM, in monolithic software, you pretty much can generate an SBOM for the entire build. Even if you have multiple libraries that you're building at one step. You're building a big fat binary. And one SBOM is going to represent the whole binary. But the question to answer as we move forward and we move from HPC to cloud native environments within the government is, of course, how do we deal with this in a decoupled architecture? Because you're no longer going to build a monolith. You're building small services, microservices. And each one of those have its own container, and each container has its own SBOM. So how do you solve that? So let's think about what that could look like. Literally, a complete software solution could have 30 to 50 unique services. And to be quite honest, I put 30 to 50 in here so you guys would believe me. Because if I put what's real, which is over 100, it doesn't seem that that's possible. Our open source project within a very short period of time had 15 or 20. It's not that big of a project. So if you're the US government, if you're a bank, if you're a critical infrastructure writing new software around cloud native decoupled architecture, 30 to 50 is a very, very conservative estimate of how many services that you could have. And each service has its own pipeline. So if you're using Jenkins, every time you build a container, one service, it goes through its own pipeline. And most importantly to understand is that it is independently deployed. right? And it is highly reused. If you're doing it right, you're building microservices in a domain structure, and you have feature teams that are building the features that other teams use. So you have an application team that could be using common code, like we used to in the C and C++ days, right? It's reusable code in the form of something built, ready to go, and in a microservice, and built like an API. So every single one of those have their own SBOM. So if you're delivering an application, which is a complete logical set of solutions, microservices that make up a single application that goes out to an end user, how do you do that? You got to aggregate your SBOMs. You have to take a logical collection of the data. So in order to comply with it, you'll have to consolidate the SBOMs. Now, there's many ways you can do that. You can have someone sit there for every single time something's compiled. I've seen Excel spreadsheets try to do this, where as soon as something's compiled, you update the Excel spreadsheet. So you have massive SBOMs and data, and it's almost impossible to look at or read. When the executive order was announced, I think it was an absolute essential piece of solving cybersecurity, but some of these gory details got missed in the process. Because while we're generating SBOMs, we don't consume them and make the data actionable. So we're going to talk about bomb control and Ortelius. Both are tools that can be used for aggregating SBOMs. Bomb control comes from the Open Source Security Foundation, and Ortelius is more of a dashboard, and it comes from the Continuous Delivery Foundation. So let's start with bomb control. So it's easy to play with. It is a basically command line solution that retrieves and manipulates and pushes multiple SBOM documents together to represent a single system. While it's easy to use, the hard part is knowing which SBOMs you should be pushing into a single solution. If you're really pushing a decoupled architecture, you may not know every single component that you consume, because you could have within an organization, and I'm not talking about open source packages at this point, you could have a component that you're consuming, let's say a login routine, and that login routine talks to another microservice that manages two-factor authentication, right? So now you have one component that you know you use, but you don't know what the other components use. So there are dependencies in this massive Death Star that we've created that are hard to understand. So while bomb control will do it for you, and you could probably use your Helm chart that says, here are all the pieces that I'm building, it can be a challenge to know what you're consuming, and that's part of the issue here. So get started with it. It works from like what they call a trees of SBOMs, where there's linkages between components and these lower level SBOMs. And it really does help the developer manipulate the SBOMs from a command line to create an SBOM that you can deliver to the US government. Again, there's manual steps in it. So we don't know how accurate it is, but at least it gives you an opportunity to provide an easy way to gather the information together and produce the SBOM. Why does it do that? Okay. So we'll talk about Ortelius now. So Ortelius, it could potentially use bomb control. Right now we don't. But it's an evidence store. And Ortelius sits on top of your CI/CD pipeline, and it consumes SBOMs for everything that's being built in the CI/CD workflow. So every time a single container is executed, it's going to go out, and we call that a microservice we refer to as a component. It's going to go gather that SBOM for that component, and it's going to version it. It's going to say, this is the version of the SBOM. So it's in an attempt to create a logical application, it tracks every single component. And it does take a Helm chart and say, this Helm chart has these 50 containers that it's building. and I'm going to make that the grouping of an application, because the Helm chart represents what's being delivered to the end user. So you could almost say our logical application represents what the Helm chart is building. Our goal is to make SBOMs actionable. And when we talk about it being actionable, we are really talking about addressing vulnerabilities that are showing up because now we are reading an SBOM. So for every component's release, Ortelius gathers information about the SBOM. It also gathers information about where it was deployed. So we have the SBOM, we have the deployment, endpoints, and then we synchronize against OSV dev to produce a report that shows post-deployment vulnerabilities. We're doing a lot of work to say, be proactive, not just reactive. Proactive, shift left, proactive. 100% it's important. But no matter how hard we try, chaos happens. And we will do a release, and tomorrow there'll be a new vulnerability. But you may not know anything about it, and it has the biggest impact on you because it's running in your environment. So what Ortelius is doing, it says every 10 minutes we're going to go synchronize with OSV dev, and we're going to tell you if you have something running in your production environment that has a new vulnerability. It goes beyond doing what I like to call point-in-time scanning, because vulnerabilities do not go to sleep after you scan, and they just go away. They keep coming, and they keep coming. 40,000 this year is what's predicted, a little over 100 a day or something ridiculous like that. So what we get is continuous vulnerability management that fits within the government guidelines for continuous authorization to operate. We are continually managing and synchronizing these production endpoints, but we don't touch the production endpoints because remember, we already gathered it during the DevOps pipeline. We don't have to go look again. We already know it's there. We're just looking at the data that we have. We're scanning against OSV dev and saying, you released this. When you released it to these endpoints, and it used this SBOM. This SBOM now is reporting you of these vulnerabilities. And we also do something else. In the side on the left-hand side, there's something called open source, Open SSF Scorecard. Scorecard makes an attempt to show the compliance level of OS packages that you're consuming. So it takes the scorecard value of any open source package you're using and it exposes the score. That is the real score for those very popular open source packages. I bet if we look today, if I was doing this live, we'd have a few yellow because teams are starting to use OpenSSF Scorecard. And the vulnerabilities that it shows here on the bottom, those are real time. This is the scanned information that comes up every 10 minutes that shows what's occurring. What that allows Ortelius to do for their end user is if there is a new problem in log4j, or in this case, I think we're looking at IDNA, you can do one single search, and that search will produce a report that shows you the component that's consuming it, the endpoint, and who it's impacting. So it really shows you that it exposes the impact of the CVE across your entire organization. Producing what we like to call a blast radius. The DoD likes to call this the threat surface or the attack surface. So for this particular one, the blast radius for this component being impacted by something like a log4j issue, it's going to impact multiple applications. So we do integrate with platforms like Jenkins. We would love to integrate with platforms like Platform One, if we could ever get in there and do some work around Platform One or Space Camp, which are some government CI/CD tools, I believe, based on GitLab. But let me just go through what we do in terms of how we solve this problem. So we consume all the DevSecOps data, including the SBOMs, and we gather the deployment locations from the logs. And then we go through and we scan that attack. We scan or synchronize. I don't like to say scan. It's really synchronizing with OSV dev. Is there any new vulnerabilities? But we only want to report on critical and high risk because those are the ones that are the most important. And it's really difficult to try to reach these policies that say you have to be 0 vulnerabilities. I don't think it's ever going to be possible, and it's impossible for developers to try to address 40,000 vulnerabilities a year. It is literally impossible to do it. So I struggle with some of these new policies coming out of these policy summits that say, your goal is 0 vulnerability, scan, scan, scan. It just is not going to happen. So what we want to do is say, fix it, fix the ones that are most critical. So what we're working now at Ortelius is through the pipeline, we want to identify the vulnerabilities that are high risk and critical, which we already can do, we can report that. Then we want to go and find the remediation. There's many places that remediation might come from, but for the most part, where we find these problems, where we have an issue, it's in what's called pinning. So when you build your container, you create a package file, a package manager like a POM file, and you identify the version of the open source package that you want to use. Now, pinning, if we didn't do pinning, the next time you built, it would automatically pull the latest and greatest. But that can cause some heartburn for some of us, because it means that you could be constantly chasing problems that are not backward compatible. And even in the secure software development framework, it says that pinning should be required, because you need to know if you're using a vulnerable package. So it's a two-sided coin, right? It's got a good side and a bad side. The good side is that you know if you have a vulnerability. The bad side is every time you build it, you're going to reconsume it if you don't fix the pinning. So what we want to do is use AI to regenerate those POM files with the correct pinned version of the package, and then create a pull request to push it back through the pipeline. Now, if there's breaking changes, we're not going to create a pull request, we're going to create an issue. What we want to do is be able to hand it back to the developers to say, here's a critical or a high-risk vulnerability, here's what we believe to be the fix in your POM file or in your dependency file, and here's the pull request for it, or here's the issue and why we can't fix it for you. You have to go fix your code. I mean, if we're successful at doing that, this open source project could potentially fix 50% of the vulnerabilities that are coming across the pipeline that everybody tells us we have to fix. So that's what our goal is. So SBOMs are super critical for managing CVEs. They are essential. And the US government requires vendors to submit the SBOMs, but we want to make them better. We want to start using them and aggregating the data to make them actionable. If you need to be able to aggregate the data, both bomb control and Ortelius can do that for you. But Ortelius will take the next step and start tracking them so that you can, if you're serving the government or if you're in the government, you can continuously track and manage vulnerabilities that are running across live assets without having to have scanning tools installed in that. I mean, think about satellite constellations, right? We can't have something running on a phone or even a satellite. The satellites are like now phones. They've got a tiny little operating system. They're not going to have the ability to have a scanning tool up there. But Ortelius can literally report on a constellation and say, for these satellites that are running in your constellation, you did an update to them on the newest version of a vulnerability. That's fixed, but the rest of them are still broke. The rest of them have some vulnerabilities associated to them. So there's a lot that can be done with kind of this digital twin that we're building inside this Ortelius database to solve the problem. And if you're interested, we're looking for some adopters to really help us move forward with the remediation process. We are going to need we need data to really understand how it's going to look. We need feedback to say, we're going to be afraid of that if you do that. So if you're interested in being part of the project, go to ortelius.io and come to one of our architecture calls and bring any questions that you have. The team is amazing. It is one of the funnest open source communities I've ever been on. We have fun, we laugh, we have a badging program to help people excel. If you have kids that are out in college who need to have experience, we're really great with working with university level students and get them really excited about tracking vulnerabilities. Or reach out to me. And please, tomorrow, 12:30 to 2:10, go grab your lunch, come back over to, I believe it's in 3C, and we're really going to talk about what is the role of AI in software, in CI/CD. Should we be debloating software? That is a question I really want answered from this group. Debloating means we're going to look at packages, and Python has hundreds and hundreds and hundreds of packages. Does Python need all those hundreds of packages? And the fewer packages that Python consumes, the more secure our software is going to be. So do we need some debloating software to go along with some of the work that we're doing? How can we do better at doing CI/CD? Because only less than 50% of the companies now actually consume SBOMs, which is a crime, quite honestly. But maybe they don't because it's just a checkbox and it just gets checked into the Git repo and you don't really use it for anything. So please come tomorrow and have a discussion with us about what's really needed. I would love to hear more from both private and public sectors. And I'll take any questions that you might have. Yes, sir.
How far down in the stack do you see the SBOM going? Obviously, running containers on.
As far down as we can go. And we need SBOMs at different levels. We need the OS SBOM, we need the container SBOM, and we need the code SBOM to really, really fix the problem. Right now, we're really looking at the code level SBOMs and the container SBOMs. We really need to get it all the way down to the OS, the operating system level. We don't see SBOMs from the Linux kernel, which we should. Yes.
So you talked about possibly integrating with tools that are based off of GitLab.
Yes.
I was wondering if you guys plan on integrating with GitLab runners themselves, like at all in the future, or is that something?
I don't know what a GitLab runner is. Is that like an action?
It's just the thing that GitLab CI/CD uses, like in GitLab itself.
Yes. The answer would be yes, we would do that. And we are in the process of doing the auto remediation. We are starting to build a Ortelius MCP server because we kind of think that that's probably going to be the easiest way to interact. And I know that GitLab is starting to work on an MCP server. So that's where we would like to start communicating, is at the MCP server level. Any other questions? Yes, sir.
So you mentioned you have a software as a service option. Is it also going to be offered standalone?
We have you can install a private instance. Yeah. And right now, that would be the preferable way, to be quite honest, because we are, we're part of the CD Foundation. The CD Foundation doesn't have a whole lot of money, so we have to get donations to support the existing SaaS model. And that SaaS model that's out there is fun to test on and it's fun to play on. But if you're going to use it, I would say you'd want to make it private at this point. Eventually, though, it should be a full-on SaaS solution. Yes, sir.
When you talk about auto remediation, what level are you talking about? Just code level, container level, all the above? Where are you guys focusing?
It's a great question. Right now, we're looking at just fixing the pinning in the POM files. That's a big chunk of it, right? So instead of boiling the ocean, we're just trying to find the biggest problem and fix the biggest problem that is the safest to fix, because we're just giving it back to the development team and saying, here's an issue, we can't fix it for you, or we fix the POM file, push it back through your pipeline to make sure it didn't break anything else that we weren't aware of. And then it would be great if we could go farther than that, but right now, that's what we want to do, just focus on the code level.
What's the differentiator for Ortelius between that and call it Renovate Bot or Depend Bot?
So Renovate and Dependent Bot, we use ourselves because it's really good for scanning the repo and doing the pre-scans, all the stuff before you deploy. We're trying to just focus on post-deployment. which Renovate and the Dependabot are not necessarily going to find. And what the other problem I'm hearing about those tools, they're great, they should be used, I'm not saying not to, they create a lot of noise. The developers are starting to ignore those pull requests, even though that there's stuff out there. So that's why we want to say critical, high risk, we're going to give you the fix on the POM file, and let's just start there.
This impacts production. Here's your pull request.
We're just there's other tools that do the other stuff. We're just focused on post-deployment. We can do any environment, but what's the most exposed right now is post-deployment, because unless you continually scan your production environments, you don't know what is out there. And for the government, there could be a release that doesn't get updated for 6 months. So it's kind of important to know that maybe there's some new vulnerabilities in there. Yeah, I know. We talk about it kind of, I've been around a while, and there's so much marketing in software. We've talked so long about the fact that we are doing frequent updates. I don't really think we're updating that frequently. Otherwise, we'd be fixing this stuff more frequently. Why is it, if we're updating on a high frequency basis, why is it over 100 days to remediate a vulnerability? I don't understand that. Because nobody's fixing the POM files. According to Brian Fox, 13% of the download, and Brian Fox is the CTO of Sonatype, 13% of the downloads of Log4j is the one that has the backdoor in it. 13%. And when did Log4j happen? 4 years ago? So there you have it. We want to fix that. Thank you very much.